All right, hello everyone. As promised, I am preparing you a short video to talk about making a class iterable in Python. And so I decided what I would do is just actually demonstrate the idea on the unsorted list class that I created a video for a couple days ago. So this is utilizing basically that same code. I have taken it and broken it into two separate files, one for my node class and another for the unsorted list. Aside from that, I haven't made any changes to that code. Now, let's just real quickly discuss what we're trying to do, making something iterable. In a nutshell, making a class and subsequently the objects of that class iterable makes it so that we can easily kind of walk through the elements in the object. So ostensibly this is some kind of container and it has multiple values or data items in it. Though strictly speaking, this idea isn't limited just to that kind of a thing. But often that is what we'll be talking about, some kind of list, so on and so forth. So let's assume it's a list. The idea is we want to be able to, instead of needing to use indexes and so forth to walk through it, we want to be able to just say, okay, get me the next thing, get me the next thing. In other words, we want to be able to elegantly iterate through it, okay? And so an example of where this could happen is if we have a list, such as here I've got test list, which is of my class unsorted list. And I want to be able to use this nice for in syntax that Python allows us to use, right? So in this case, I'd like to, for each of these underscore items in test list, just print it. As it currently stands, if I try to run this, I get this error that says that the object is not iterable, which of course is the topic of our conversation. If this had been a Python list, this would have worked, right? So we're trying to kind of replicate that behavior here. All right, so how are we going to do this? Well, for something to be iterable in Python, two things need to happen. First of all, we need to be able to retrieve an iterable object from it. Okay, and then on that iterable object, we need to be able to call a next function. Okay, so that means then that on test list, we need to either override the iter method or override both the iter and next methods. We'll make clear the difference between the two in just a moment here. So to begin with, what we're going to do is actually just try to make our unsorted list itself be an iterable object. So let's go to the definition of that class. And so to make objects of this class themselves iterable, we're going to implement both of those methods, iter and next. So let's talk about next first, because this is actually the method that, purely speaking, makes something iterable. It's the method that returns repeatedly the next item that we want to retrieve from the object. Okay, so I'm going to go ahead and put this method right here, right underneath my constructor, just keeping things near the top and easy for me to see. So what does this need to look like? Well, the name of the method has to be the dunder next followed by the double underscore again, and it takes self as its only argument again. So let's talk about what it would mean then to kind of iterate through the contents of our list here. So we're using a linked list in order to store the data. And so the way we traverse through that linked list is by using pointers and so forth. In this case, we need to use a pointer to walk through the list, right, in order to be pointing to the next value we want to display. But we need to both be able to, when this function is called, we need to both be able to advance to the next item while also returning an item, right? And so if you think about that for a minute and you try to write it down, and hopefully many of you have already thought about this and wrestled with it a bit, it ends up kind of being mind-bending, right? Because we need to both advance and return kind of at the same time. So a nice way of doing that is actually to use two pointers. We've done this before when we were dealing with the issue of removing a node from the list, right? We had a pointer pointing to the node that needed to be removed. In order to remove it, we needed to be able to point to the node in front of it so that we can make that node point to the one following it, okay? So we're going to use the same kind of idea here. what we will do is we will have this notion of, let's see here, the current node, which is going to be the node whose value we want to return when next is called, okay? And that's always going to be one node behind the next node, which will be the node that has the value we want to return the next time they call next, okay? And then so each time we're going to advance our next node to point to the next node, right? Just following those pointers. But then the key here is that we will return the data from the current node. Okay, so if you think about it, the next time that next is called, the thing pointed at by this pointer will become the thing pointed at by the current node, and that's the data that we will return. So this will be a pattern that will allow us to walk through the list, always returning the current value while getting ready to return the next value. Now, for this to work, we have to, of course, initialize this stuff properly to begin with. So, as I said before, we're actually going to make the unsorted list itself be the iterable object. And so to complete the process, we have to override both the next as well as the iter method. And so here is the iter method. And what we want to do is we want to, when somebody tries to get the iterable object from unsorted list, again, it will be the object itself in this case, but basically we want to make sure that we get ready to iterate, right? We need to set things up for that. So what we'll do then is we will set up this current node pointer to point to nothing, okay? And we'll set up the next node pointer to point at the same node that the head points at, and then simply return ourself, right? Return this object itself. So if you think about it then, the first time next is called, current node will be set to none to begin with, but that doesn't matter because we're immediately going to override that. We're going to overwrite it, excuse me, with the value in next node, which will be the head. Okay, so the value, excuse me, the head node, the pointer to it, is what's going to end up in current node, and so we'll get the data from the current node the very first time you call next. And of course, next node itself, this pointer, has already started to look ahead to the next value. Now, we need to make sure we take care of the case when we're ready to finish. In this case, that's going to mean that the next node, right, the thing we're supposed to return next, has fallen off the end of the list. So if we simply check for that to see if next node is none, oh, started putting parens. I'm teaching C++ at the same time that I'm trying to teach this class, and so this is going to happen. I'm gonna mess up syntax. All right. So if it turns out that next node is none, then we immediately just want to stop. So we'll raise the stop iteration, and that'll cause the iteration to cease. Okay. So let's give this a try. We've made unsorted list iterable. So what should happen here in main when we attempt to use this nice for in syntax, test list should be queried for an iterable object, right? So in other words, this iter method should be called on the object. It's going to set up those two pointers, current node and next node, and then return itself. And so then that object that was returned is assumed to be the iterable object, and so next will be called on it each time we iterate through this loop. Okay, and so that should cause this underscore variable to be being assigned whatever was returned from next each time, and that should be printed. So let's try and run this, and voila, we see that we're able to iterate on our test list. Now there is a minor or not so minor problem with this. Now if this is what you do for the lab, that's totally fine. Okay, we're not gonna, like, this is acceptable for the lab. You've made it iterable, it's doing its job, and you'll complete our tests. However, I do want to point out there is a situation in which this will break down what we've currently done because we've made the object itself be the iterable object that gets returned. Why do we care? Well, let's assume actually that we have a nested loop, okay, in which we're doing something with items from this list. So I'll show you what I mean here. That we're doing something with items of this list in both the inner and outer loop or loops. So in this case, all I'm doing is trying to print the string representations of whatever these values are. Okay, so our list has in it the values -5, 7, 43, and then of course we appended 7 at the end, so our list looks like this. Let's watch what happens when we run this. We would expect, okay, in fact, give me a moment here, let's change this. Let's indent the printing that's coming from the inner loop so we can clearly see where the output is coming from. So what I would expect is to see the values of the list being printed one at a time from the outer loop, but after each value I would expect the entire list to be printed from the inner loop. So we'd expect to kind of see this in our output, kind of the stepped output, right, where we see -5 and then we'd see the whole list, then we'd see 7 and then we'd see the whole list and so forth. When we run it though, actually, whoops, what did I do wrong here? I'm missing a paren there. There we go. When we run it though, actually we only see part of the process. We see the -5 printed here, but then we see, the entire list printed from the inner loop, which we expect, but then it stops. Okay, so what's happening? Well, what's happening is that both of these loops are using the same iterable object because our iter method on test list is just returning itself. So both are using the test list itself as the iterable object. In other words, next is being called by both loops on the same object. Okay. Now in both cases we also called that iter method, so both of them kind of did this step right here where we initialized current node and next node. So the outer loop did this and then managed to call next one time, so it printed the first element in the list. The inner loop also called this, which effectively reset current node and next node. So then when it called next, it printed the first item again, and then it continued calling next and printed the other items, which is what we wanted. The problem though is that by the time that this inner loop finished its first set of iterations through the loop, through the list, it has advanced then those pointers that are being used by next to the end of the list. So when we loop back up here on the outer loop and it tries to call next again, remember it's calling it on the same object, and so the pointers are already sitting at the end, and so it's finished. It doesn't go any further. Okay, so in order for this to work the way that we expect, we actually need to be getting different objects that have their own state when we try to iterate. Okay, so how do we do this? Well, this involves creating in some way we have to create a different object when we call this iter function. So there are a couple ways we could do it. We could make a copy of the object itself and return that, in which case each of these loops would be operating on a different object, and so they wouldn't be calling next on the same object. They'd each have their own object with its own state, and so these loops would behave properly. So that's one route, is to just return a copy instead of just returning yourself. That may or may not be a good idea. One reason it might not be a good idea is that we don't necessarily want to have to create a whole copy of a new list and things like this. Another approach might be to actually return just a stripped down version of the object, right, that only contains what's needed in order to iterate through the object's information, through its data. So in this case it's a linked list, meaning that if we have a pointer to the beginning of the list, for instance, then in theory we should be able to use that to iterate through the list as if we were the object itself, right? So All right. So what I'm suggesting here is, if this is our unsorted list object, then it has a pointer inside of it we've called head that points somewhere in memory to our actual linked list. And what I'm suggesting is that when we call the iter function on this object, instead of it returning itself as the iterable object, that maybe what we do is we create another object, right, that's simpler, less complicated, that also has a pointer to this list. And that it's on this object that we sit and call next, and it does the job of walking through the list. Okay? And what that would do for us is that if we tried to iterate on this list multiple times, tried to get an iterable object from it multiple times, we could simply be providing multiples of this smaller, simpler object that could be used to iterate through the list. And so since, as you can see, both of these have their own pointer or set of pointers, as it's going to be in this case, then if we have different loops or nested loops trying to iterate across the list, they won't conflict with each other. They won't mess each other up. Okay, so let's look at how we might do that then. What I'm going to do is, here in my unsorted list file, I'm just going to create another class. I'm simply going to call it iterable unsorted list. Okay, and what I'm going to do is, for its constructor, not only will it expect self as a parameter, but it's going to take in a list as one of its parameters, and this will be the key here. And so then what we'll do is, this iterable unsorted list class, each object of this class will have its own current node pointer, which again will begin by initializing to none, and it will have its own next node pointer, and here's the key, which we will set to be equal to the head pointer of the list. Okay, so this has effectively set these pointers up the same way that the corresponding pointers were set up. I can find it here. Okay, you'll notice these are effectively being set up the same way that we were setting up their namesakes inside of the unsorted list class. The key is that we're doing it in a separate class where we can create these separate simple objects that are just pointing to the same list. We're going to be able to access the same list. All right, so this is supposed to be the iterable object, so of course it needs to have, or objects of this type need to have themselves, the next method. And it will do, conveniently, because we've chosen our syntax wisely, the exact same thing. Okay, since we named those variables inside of this new class the same way, we can actually just copy and paste our code. Oops. Oh wow. How many ways can I do it wrong? Okay. There we go. All right. So now objects of this class should accomplish the same task as the original object did, except that now we're getting a new object each time we'll call this iter method. Of course, we've got to make that actually happen. So we're no longer going to need the next method on the unsorted list class, because it itself will no longer be iterable. But what it will do is, instead of setting all this stuff up on itself, it's going to return an object of the, needed to look up the name there real quick, iterable unsorted list class, which will be initialized using this object as the only argument that needs sent to it. Okay, so in other words, here in main now, when we try to iterate over this list, it'll call iter on the object, which will return an iterable unsorted list that's initialized with the current unsorted list as its argument. We see what happens here, that the head node is used to then initialize the next node pointer in this new object, and then that sets everything up properly so that every time next is called on this object, it will actually be walking through the list that belongs to the unsorted list. Let's see if that works now. Voila. Oh, my output's garbled here. There we go. So here you see the outer loop, okay, walking through the list, -5, 7, 43, and so forth. And each time we get one value from the outer loop, we're printing the entire list on the inner loop. And they're not interfering with each other. Okay, so again, if you want to take kind of the lazy way out for this particular project and just make the object itself iterable and return itself as the iterable object, that's acceptable. If you want to be a little bit more robust and create that second class and return an object of that type, that's also doable, and I think that I've given you enough here to be able to do that. So either way, it's up to you, but hopefully you have a better idea of how this all works now. I'll see you in class and talk to you later.